Well, hello everyone, and good morning, good afternoon, and good evening to anyone who's watching us live right now on YouTube and on Twitch. I'm so excited to be your host for today. My name is Tamimi, and I'm a developer advocate at Solace. Today, this is going to be our first event. This is our first episode in a series of virtual events we're hosting at Solace. We have two types of virtual events. We have a live coding events and a workshop events. And today's live coding event we're going to be talking about AsyncAPI and learn how we can design and generate code to build an event-driven application. I'm so excited to have this event today, and we're going to have everyone to be interacting with us online. Just a few housekeeping things to say. We have a poll we would like you to fill in. You can see the QR code and the link down on your screen. So feel free, please pick up your phone, scan this QR code, and fill this poll. I assure you it'll take less than 12 seconds, even less than 10 seconds to go through the questions on the poll. The reason why I wanted to do this is kind of to see where we can find you better and kind of like tell you about our upcoming events. So without further ado, I would like to introduce our amazing guests for today. First, we have the founder of AsyncAPI, Fran Mendez, who's going to be joining us today in the call. So I would like to introduce Fran to the call with us today. Let's see, Fran.
Hey, Tamimi. Hey, look. And also my cats are around. So.
People are laughing at you. Looks like you have a very good audience.
That sound effect on top. Oh my! This is so professional. So thanks for inviting. As I was saying, that you will see me here today, doing some nasty coding things and with the Solace folks and probably with my cats, because you probably can see my cat going through the camera right now. So yeah, she's now trying to take attention. So you'll see her.
I'm so excited to have you for the call today. It's going to be a fun, interactive session where we'll chat with you and your cat. We'll interview you and your cat on a couple of things. Next, I'll want to introduce Marc, our manager of developer relations team. So Marc is in here, and Marc, you also have a bunch of people clapping at you right now.
Woo!
Look at that.
Oh, thanks for having me as well, Tamimi.
There's an air horn in there.
Oh, geez. Right, excited to kick off this first episode with yourself and with Fran joining us, obviously, from AsyncAPI. And for anybody that doesn't know, I'm a developer advocate at Solace with Tamimi. I'm based out of Orlando, Florida.
Fantastic. Thanks for joining. Before we get starting with the icebreaker questions, I'm asking you guys a couple questions. I'd like to remind the audience, whoever is watching us right now on YouTube and Twitter, you can ask any questions. So your audience questions are accepted in chat. So feel free to put some comments in your chat, whether you want any questions, emojis, or anything you want to tell me or Marc or Fran. Just type it into the chat and we'll see it. So before we get started, I wanted to ask a quick question to Fran and Marc. What do you guys do outside work, outside AsyncAPI and outside Solace? So Fran, I would like to know, what do you do outside AsyncAPI before we delve into the nuts and gritties of AsyncAPI?
That's a good question. If you find the answer, please tell me. So far, don't do much. We cannot go out, so we can already go out. But just kidding. I usually like to just play volleyball, mostly indoor volleyball. But now it's gonna be soon the time for beach volleyball as well. So
nice.
So that's my other passion. And I'm terrible as well at volleyball. So so yeah, but I love it, especially the beers afterwards, right?
Yeah,
that's the part that I like the most.
I go for the beer too. Yeah.
Yeah. So for me, kind of the similar thing, right? Like I'm a sports person. I like to watch sports and I like to try to play sports. I used to be good at basketball, but it's been a while. And I like going around to once we open back up, I like going around to some of the conferences and traveling and stuff. Traveling is a fun hobby for me. So kind of shut down by the pandemic right now, but hopefully that will go back to normal soon.
Yeah. Oh man. Okay. Well, thanks for telling me what you guys do outside what your day-to-day work is.
No, you sorry to interrupt, but you have to tell us.
Yeah, you tell us what you do.
I shouldn't be.
Come on.
Well, on my free time when I'm not doing like work, apart from just like hanging out with friends, I picked up DJing recently. So I've been doing like a bunch of DJing. So because I'm not going out, I've been DJing at home, practicing a bunch. So this is something that I'm like really interested in. I really like music. So yeah, that's what I do outside Solace.
Is that where the air horn and clapping came from?
Exactly. Yeah. I have a big pad over here. I just put like air horns.
So next event we'll have Tamimi on the.
Hey, I'm putting fire and mixing beats.
DJ Tamimi.
DJ Tamimi. Well, DJ Tamimi, that's a good segue for our next question. So, Fran, this question is for you. I'd like to, if you could give me like an overview on your journey to finding AsyncAPI. Why did you find AsyncAPI, and what's the gap that you were trying to fill with finding AsyncAPI and making it like a big initiative?
That's a good question. I never thought that I was going to found AsyncAPI or anything. So to me, I was just working on a company. It was called Hitch. It was an API changelog company, and it was an API changelog working with OpenAPI mainly.
Right.
So we were used to OpenAPI for everything, and we had a distributed architecture with RabbitMQ in the middle. So yeah, so we have an event-driven architecture. API as a changelog is actually a series of events, right? So it made sense. So what happened is we didn't have such tools that we have for REST APIs for event-driven APIs, right? Or for event-driven microservices in this case. And therefore, what I did was let's try to adapt OpenAPI for our use case. When I say get, it means subscribe. When I say post, it's a publish. It did the job more or less for documentation, but not for code generation. And it was like a big hack on top of OpenAPI, right?
Right. And what was this? What's the timeline? Like, what were we talking about? Like 3 years ago?
Yeah, it was 2016, 4 years ago. Actually.
Okay. Yeah.
And then I asked the OpenAPI people, like, hey, do you have plans to include other protocols and methods and all this stuff? And they say, like, no way, man, it's too much, right? It's already too much as it is, and I understand. So yeah, I decided to just hack myself OpenAPI and remove what wasn't needed and add the needed stuff and created AsyncAPI. But I never thought it was going to be used by anyone else other than me. but my default always was with AsyncAPI and with any project, and you can see my GitHub profile is I was always doing everything open source by default,
right?
Unless there's a reason to keep it private,
a
legal reason or something. So it was also open source, and I was speaking about it on events because I thought it was a cool idea that somebody had to explore. I never thought it was going to be me.
Now you know how much work it really is.
Yeah, exactly. I was already envisioning like this is too much. I'm not gonna do this in my spare time. Famous last words, right? So, yeah. So I ended up doing this on my spare time until it was impossible to.
See, that's the nice thing about open source. Sometimes like you just put things open source and then you start getting support from the community. So like. You founded AsyncAPI in 2016, And fast forward, now you have a bunch of different organizations and people who are supporting AsyncAPI and contributing to the open source repositories on GitHub. And you guys have like a very cool website right now. And this is kind of the nice thing about this. I know, like, I wanted to kind of see when did Solace kind of like get into this timeline? So Marc, to you, like, how is Solace supporting the AsyncAPI initiative and organization, and like how did it, like, through this timeline starting, let's say 2016, where did Solace get involved in this, and how is Solace supporting the AsyncAPI initiative?
Yeah, for sure. So I don't know the exact times. I'd have to go look that up. But I kind of had a similar background myself a little bit to Fran, in that, you know, I worked for large organizations in like the aviation space and the weather space and the healthcare space, and, you know, all of these large organizations were global, and we needed that. You know, we had event-driven systems because we needed to keep up with the real-time data and make real-time decisions, and we came to the kind of the same conclusion at those organizations, in that like the tooling wasn't there that we needed.
Right.
And so in some organization, we tried to adapt service registries that were available to kind of like store your topics. In other organizations, we built custom systems to kind of handle what AsyncAPI does now. Mm-hmm. And so, you know, that kind of drove me myself, actually. I was a customer of Solace and a user of other messaging systems before I worked for Solace. So I came on and started working at Solace, I think it's been about a year and a half ago now, when I heard about the Solace Event Portal and the initiative that they were working on with AsyncAPI. And so since then, I think from a Solace perspective, at least since I joined, I know, you know, we've been contributing via documentation, via helping, you know, Fran and the team figure out maybe where to take the spec in certain cases, giving our opinion. Of course, you know, one of the cool things for us is code generators that we'll talk about more in a little bit. So we, one of the members of our team, Michael Davis, was the lead developer on the Spring Cloud Stream code generator template. And then, of course, we're doing other things like sharing via conference talks, this virtual developer workshop, and we've also done some hands-on workshops with AsyncAPI, you know, with some of our customers.
Right.
And then, of course, I think, Fran, let me know if I'm wrong. I believe Solace, you know, as one of the platinum sponsors, is still the largest. We have the largest amount of funding towards the initiative.
Through Open Collective, yes.
Through Open Collective. Okay, cool. Yeah, so we're also funding and helping.
Let's leave it there.
That sounds good. So we're also funding and helping, you know, Fran work his magic on his end and push AsyncAPI forward.
Nice. Yeah, no, that's great. And I see people like are commenting on Twitch. Aaron is like, he found AsyncAPI about 3 to 4 years ago and surprised anybody else was talking about it, and he's happy that it's growing. Thanks, Aaron, for the comment and your input on this. Speaking of that, Fran, how are organizations and developers using AsyncAPI? Like, yes, AsyncAPI now it's an open standard, it's an open source, and, you know, it's defining the direction of where asynchronous development is going. But how are organizations? Do you have like any examples on how organizations or developers even are using AsyncAPI nowadays?
Yeah, we find like a very broad set of use cases, if you want.
Mm-hmm.
For instance, you have a lot of use cases, more than I thought there will be, about using WebSockets,
right,
APIs, public WebSockets APIs. Like it's the case for Slack, for instance, and HTTP2 servers and events.
Mm-hmm.
And when I created it in KPI, in my mind, it was all going to be around AMQP, MQTT, you know, Kafka at the time was floating. But I never thought about these other protocols, right, and patterns.
Right.
So I see unexpectedly, I see a lot of people using the request response, not the request response, but more like the client server type of architecture with messaging, like in the case of WebSockets or service and events, right, where you don't have topics, you have a single connection and everything happens there. And then you also have these other kind of companies and organizations. You can hear my cat, right? So you have all the other kind of organizations that use it for something completely different. Right. That's on the technical aspect. Let's say on the business aspect or use cases more or not super related to technology will be some people do it to coordinate or use it to coordinate the teams, teams of developers. Agree on documentation, on the message format, on the fields that you can find there, respect there. As a developer portal, if you want, right?
Yeah.
And that's to me, that's the main use case, aside from providing a public website where people can consume your documentation.
Right.
In the case of Internet of Things, for instance, this is very common.
Yeah. You mentioned a very good point about the documentation where teams could use it to document their asynchronous applications. So when I first got introduced to AsyncAPI and saw what are the things you can do with the specs, the first thing that came up to my mind is Swagger, an OpenAPI. How Swagger is used, an OpenAPI is used to define your REST APIs. AsyncAPI is there used to define and document your asynchronous APIs. So the way that I first thought when I was introduced to AsyncAPI a couple months ago, so not so long, the way that I was able to understand it and wrap my head around it is all right, there's a REST way of doing things using, OpenAPI and Swagger, and you could document it and you could generate code like REST API code from your Swagger specs. And the same idea, there is AsyncAPI that you can document and have a set standards on your event-driven application. Cool.
Yeah. Totally. Yeah, totally. Yeah. And you mentioned one thing is that I think that the easiest way to start using AsyncAPI is through documentation, because it's safe, right? It's very safe. It doesn't affect your production systems, and it's useful. It's already useful for your teams, right? But we're seeing more and more demand for people wanting to use AsyncAPI for management capabilities, right? So like you have REST APIs gateways that are powered by OpenAPI or Swagger descriptions. Same thing, right? So gateways that sit in the middle between the consumers or the producers,
right,
and the broker, and basically apply policies to the messages in the middle.
You can use that to document how you want the whole the flow of the messages and how the messages relate to each other and what are the different kind of schemas that are being done with the messages. Okay. Yeah. No, that's great. You had your first AsyncAPI conference a couple of weeks ago.
Yeah.
Congratulations on that.
That's thanks. That was crazy.
It was awesome,
and exciting. It was all of this at the same time, right?
About how people were very happy about joining, attending the AsyncAPI conference, and I was so impressed how it was all done within 3 weeks.
Less, 2 weeks and a half. Yeah,
2 weeks and a half. Yeah, anything less than 3 weeks, you have to be precise. It's not 3 weeks; it's 2 weeks.
But we must say something. We had nothing else to do. We were in a confinement, right? We were in a lockdown, so we were actually bored at home. And it's I don't want to think more on the lockdown, so let's do something to forget about it. That was a little bit of an excuse.
Yeah,
and also at that time we thought that this is probably going to end up soon. It's going to be finished soon. The lockdown and all this pandemic and all this stuff. We should do it quick, because if we do it in 2 or 3 months from now, maybe nobody is going to attend, right?
Right, and it was well organized. So well done on that.
Yeah. It was crazy because I remember it was on a Tuesday SIG meeting. We're like, hey, who's interested? And then by Thursday, the website was up.
Well, I mean, templates.
Yeah.
There's a way. Yeah. Templates. You did mention in your talk, Fran, during AsyncAPI conference that AsyncAPI, you're working on a bunch of different tooling. There's a bunch of different tools with AsyncAPI, one of which is the generator. And I know Marc mentioned, touched a little bit on the generator. Can you talk about tooling and in specific about the generator as a tool to be used with AsyncAPI? Because this is kind of what I'd like us to focus on today's session. So tell us more about your the tools and the generator with AsyncAPI, please.
Sure. So I think our way of thinking about AsyncAPI, in the beginning, it was more about the spec, only the spec, and the spec was the primary thing, and everything was surrounded the spec. But more and more we're seeing that as it's normal, nobody cares about the spec, right? It's like people want to use tools. It's like just give me something that tangible, right? Something that I can use, and yeah, it's powered by the spec and all this stuff. But I don't want to learn the spec, right? Or I'm not interested in that precisely. I might have to learn the spec because I want to use that tool, right? It's not the opposite. It's not the other way around, right? So we started thinking more on the use cases that people and talking to different people. What were the use cases they were expecting from AsyncAPI, and also identifying the easiest parts that we can start working on. And again, the documentation generation, code generation seem to us like the easiest one to start with, that provides a lot of value. And yeah, so we started there, and that's Generator actually. So Generator is a tool. It can be so generic tool if you think about it, that it works for AsyncAPI, but with very little tweak, it can work for any other specification. So what it does actually is it takes AsyncAPI as the input, and a template of files, a set of files that's what we call a template, and it generates a resulting set of files, right? And so with this system in place, you can generate docs and code. Of course, you can generate whatever you want. And as I was saying, that we were even joking the other day, Lucas and I, that with very little tweak there, we can even make it work with OpenAPI, RAML, JSON schema, protobuf, whatever we want. Right? And we can add more rendering engines as well. Like we're now exploring on making it work with React.
I saw you put that up. That's
so it's like it's super easy to plug new stuff in. We probably will not go in this direction, because then it will become something like very generic, and it's then gonna be difficult to explain. But yeah, it's like this is more or less the main tool that we have, and below or behind this there's the parser, right? The parser is the one taking care of reading the file, the AsyncAPI file, and converting into a model, right? That code can consume. So
And I think right now, so that basically when you use the generator, you choose which template you want based on what you want to generate. And so I think right now there's generator templates for NodeJS, Python, Java Spring Cloud Stream, and then from a docs perspective, I think it's HTML or Markdown, right?
And also there's another Java Spring.
Java Spring as well. Okay. Yeah. So today, when we jump into the live coding session, we're going to be looking at the Java Spring Cloud Stream template, and then I believe the Node.js template, or is it the Node.js WebSocket template, Fran?
It's a Node.js template. It's a generic one.
Okay.
We're going to be using both. You're going to be using the Java
Spring Cloud Stream.
So fucking long name.
I didn't name the framework. I like it though. The framework's a nice framework.
It's a nice framework, but it's a long name.
No, this is great. Thanks for touching on the code generator and the kind of the polyglot support of multiple different programming languages that it supports. Before we jump into the live coding, because I'm excited to get into the live coding section of here. I just want to remind anyone who just joined us right now on YouTube and Twitch to fill in the poll. So you will see we have the QR code at the top over there next to Fran's face. So feel free. Yeah, there you go, Fran. Thanks for pointing to this. Feel free to
a regular Vanna White.
And or you could just go to this link. It'll take you 5 seconds. It's just 2 questions about like where did you hear about this, and what's your role? So fill in this this poll, and we could go ahead and jump into the core of what we're going to do today with live coding. Before we do that, Fran, quick question for you: did you ever go to New York City before, or no?
Yes.
You did.
What I did twice.
Kind of iconic things that you've seen in, like, when you think of New York City, what is things that like pop in your mind?
You don't want to know. No, I can tell you a brief, like, I can tell you a story there.
It's New York City.
Something good about the city that happened to me. It's like first time I've been in New York City. It was like 12 or 13 years ago, and it was to participate in a breakdance contest. Because yes, I was a professional breakdancer, like around 15 years ago. And we were also competing in Los Angeles. So yeah.
So now we know what's going to happen if we're going to take a break in a little bit, and then Fran's going to break dance.
Yeah, Tamimi is going to be a DJ, and I will be dancing.
Yeah. I think I'll
that's what happens when your head spins so much, and when you spin so much in your hair.
Yeah, no, this is great. Well, I'm glad to know one more thing about you, that you were like breakdancing in New York. One other things that I think of as well when I think of New York is like they have a lot of taxis over there, and when I watch like movies and shows about New York, everybody's standing on the street and hailing a taxi, a yellow cab. So I will let Marc introduce our application. But in the meantime, so there is the QR code. You could check it out, and you could join our Solace community as well. In the Solace community, you will stay up to date with what we're up to. So you can see down low, we have the Solace community website, and you could also use your phone to scan the new QR code up there to, yes, thanks, Fran, to join our Solace community. So this is what we have, and without further ado, Marc, can you please introduce us what we're going to be doing today? What is the idea that you have in mind that we're going to be working on? And in the meantime, Marc, go ahead and talk about the application.
Yeah,
and
sure.
In the audience, if you have any questions, comments, suggestions, or anything, feel free to put them, like ask your questions. I will be monitoring, and we could even highlight your question on the live stream. So if you're the lucky one, if you're the chosen lucky one,
we'll answer more than one question. Yeah. So if you want to share my screen, Tamimi.
Sure.
And so essentially all the code throughout this live stream, we're going to go ahead after and throw in this GitHub repo. So live coding AsyncAPI Code Gen. But what we're going to do today, since you mentioned New York City taxis, essentially we're going to use some data here that the New York City Taxi and Limousine Commission kind of made public. So they had an open data release of over 1 billion taxi ride records, and essentially Google took those and said, hey, in the release of data, they basically released where pickups happened and where drop-offs happened.
Right.
And since we all know Google knows how to do maps, they decided to map the routes of each of those rides and made that data available. So what we're doing is we're taking that data and publishing it into Solace PubSub Plus. And so essentially taxis are sending in taxi updates that include information like the ride ID, where they're at with latitude and longitude, the meter increment, the number of passengers, etc. And so that information is being published onto a topic hierarchy in Solace. And so it's in an asynchronous manner. The taxis are publishing in. They don't know if anybody is consuming those events or if 100 applications are consuming those events. So in a asynchronous manner, Fran and I are going to build out 2 applications that use those events.
Marc, a bit?
What?
Can you zoom in?
Maybe. I think I've already, here, is that better?
Yeah, that's better.
Yeah. So what we're going to do is we're going to receive those events. And so the initial events are being published on a topic hierarchy that uses variables here that allow us to do filtering on the exact events that you want. So we're going to create a ride drop-off processor using Spring CloudStream. And so I'm going to consume on this T2 topic. And so T2 is basically filtering on just ride status of drop-off. And then I'm going to use a greater than sign, which is a wildcard. And so that will get me, it doesn't matter how many passengers, what the ride ID is, or what the longitude and latitude are, of where the taxi is, I'm going to get all of those events. And so what this application is going to do is basically window those events and calculate some averages. So it's going to publish events back in to our event broker that include like the average meter reading and the average passenger count over a given window. So for this, I'll probably use a window of like 20 seconds or so just to keep things moving along. And then Fran is going to use the NodeJS generator template to generate an application that listens over MQTT, I believe, and it's going to listen for these drop-off average events.
Right.
And so, I guess without further ado, we'll jump into the design here. So we have this, this high-level architecture diagram, kind of like a business level of what you want to do.
Right.
So now, of course, we need to kind of design that, and so we're going to use the Solace Event Portal for that. So I'm logged into Solace Cloud here. And so for those of you that are not familiar with Solace Cloud, I'll quickly show, like, you can launch messaging services in here. You can build your event mesh kind of around the globe to decide, where your events can go and where consumers can connect into US or to a service in Europe or in Asia, right, to consume the events. But what we're going to use today is the designer. Mm-hmm. And so we're looking at New York City Taxi Company. And so if I go into New York City Taxi Company, right now...
Cut you off a bit. So we have a question coming in. So with this architecture that you just showed us earlier, would it let you filter based on passenger count regardless of the ride status? So based on the topic hierarchy that you showed us earlier?
Yes, for sure. So essentially, in MQTT or in any of the Solace supported APIs, these slashes here, the backslashes, represent different levels. And so you can wildcard at an individual level or use like the greater than to get everything. And so for me, we're going to use the greater than because I just want drop off. But if I wanted just passenger count, I could do V1 asterisk and then passenger count of like 2 and then slash and whatever else I want.
Right. I hope this ends.
And I also want to say one thing here as well is I do say filtering. Now, from a filtering perspective, the way the Solace broker works is it actually filters at the broker. So it doesn't just send all those events over the network to you and then your application is filtering and throwing it on the floor. It is actually on the broker side, it knows what your application wants and it will only send the events to you over the network that you have selected, that you've subscribed to essentially. So I think that should answer that question, but definitely if you have follow-up questions, go ahead and throw those in the chat.
Right, thanks, Marc.
Yeah, no problem. And so if I go back to the event portal here, we basically just have taxis sending that taxi status update event into the portal right now. So what we want to do is we want to add our ride drop-off processor. So I'm going to go ahead and add that first. So if I create an application here and we'll say ride drop-off processor. We'll start with version 001 and we'll say this is a Spring Cloud Stream app or a microservice.
Right. And you're creating this application that will consume the stream on the topic that you showed us in the architecture diagram overall.
Yeah, exactly.
Right.
Yeah. So from a design perspective, right, because a lot of times your architects will be the ones putting in the designs. You want to have a name of an application, an initial version, add your description. In this case, I'll go ahead and add myself as the owner here, and I can tag it. And so the tags in the portal you can tag for whatever you want. In our case, I like to use SCST, that stands for Spring Cloud Stream. It's a little bit shorter for you, Fran, so we don't have to say Spring Cloud Stream over and over again. And so that you can filter on tags and stuff as well.
Time.
Yeah, exactly. and then so, in here, we want to consume those taxi events. So if I come in here, I can basically search my catalog of events, and I have taxi status updates. So I want to subscribe to those, and I want to publish. According to my architecture from before, I want to publish kind of this event. So I'll call that event maybe like a ride average update. So I need to create that because this event doesn't exist yet. So if I say add event, and we'll say ride average update. And so we do have a shared checkbox here, and this would allow you to share it across application domains, which is kind of a concept in the event portal as a way of like separating your organization. So it could be different projects, different verticals of your business, or different software development teams. For now, I don't want anybody else to mess with it since I'm just developing it, so I'm just going to leave it internally to me to modify into my New York City taxi company application domain. And for this, I'm just going to say, yeah, this event contains the average cost in passengers.
So Marc, what you're doing now is you're just kind of like designing your architecture. You're still not coding. You're still not kind of like doing any code generation. You're just designing the overall architecture and how you want your different microservices and different applications to interact with each other, basically.
Yeah, exactly. And so I'm defining the event, and I'm defining which topic it will be available on. And so this allows you to kind of have that decoupling that is kind of like sold to you when you go when you want to go event driven. You know, one of the benefits is being decoupled. So you know, my publishers don't have to care where my subscribers are or what they're subscribing to, and vice versa. My subscribers don't care who's publishing what. So in this case, I'm saying, as a, you know, this event is going to be published on this topic, and from a publisher perspective, I'll do that. And then as a subscriber, you know, they can look at the topic space available and decide which events they want to subscribe to, and you know, do the filtering like we talked about before, just to pick the specific ones that they're interested in or not interested in.
Cool.
So I think what I said is this will be stats drop off average. So I look at my picture. I just want to make sure I match it here. So we said taxi, New York City, V1 drop off. Sorry, V1 stats drop off average. So yeah, V1 stats drop off average, perfect. And then I need to add my payload schema. And so, you know, as part of my event, of course, it includes the payload, and that's where the actual data is stored. So we'll call this ride average payload, and it's going to be in JSON. And so just to make this easy, it's easier to create kind of a sample message. So I said, all right, what's going to be in this event? We want to know the timestamp, the average meter reading. What?
Zoom in a bit on this.
Ah.
Yeah.
Tamimi just likes to make fun of me that I suck at zooming in.
No,
so it's also better. I did it. All right. So timestamp, average meter reading, average passenger count, window duration seconds, and the window ride count. So this would be kind of the number of drop-offs during my window. And so I'm just using JSON schema.net. I'm going to click submit. And this creates a draft schema for me. So just to make sure everything looks good here, I can see, let's see, my timestamp is a string, average meter reading is a number, window duration is an integer, which makes sense. I'm going to do full seconds for my duration. And ride count, again, is an integer. We're not going to have partial rides.
Right.
So all this looks good. So I'm going to go ahead and copy this schema, and we'll throw that in over here. And I'm just going to say this is a description of the payload, so I don't have to make up something there. All right. So if I save that, it created my payload and automatically attached it as the payload schema to my event.
Right.
And again, I'll go ahead and throw myself as an owner here. And I'll go ahead and save. I don't have any tags off the top of my mind. All right. So now I've created my new event. It's tagged as new, and I say this is the event that my application is going to publish. And so when I click save now, I can see my new application, the ride drop-off processor, is created. And the ride average update event that we just created is also on the graph. And so now just to wrap up our architecture in the design portal, we need to add the ride drop-off consumer. And so I'm going to go ahead and add that. Ride.
So literally what you're doing is you're just kind of like still, again, kind of defining your end-to-end architecture, how you want it, like what are the different microservices that are in your architecture and how they interact with each other. Like do they subscribe or produce any events on particular topics. And you're just defining every topic and what are the payload schema for the topic. So it's all like right now we're in the architecture design phase. Yeah, exactly. So, you know, I'm adding my applications in and I'm choosing which events they subscribe or publish to. And so the reason for this one is because I had a high level architecture, so now I need to define it further in one place so we can actually develop that.
but also because it's going to allow me to make that development process quicker, which I'll show in a second, via the use of AsyncAPI, of course. And it also allows me to really visualize my architecture because sorry, let me go ahead and grab this taxi event. So I want the ride average updates when I was subscribed to here. And so if I save that, we add this new event, or the new application that subscribes to that event. But because these applications are decoupled, it's hard to sometimes understand what's going on in an event-driven architecture. Historically, you have events flowing over your broker, whether it be Solace or IBM MQ or a Kafka or a Rabbit, and you kind of go to the middleware team and say, all right, who's sending what, or what am I receiving, or you have to go dig up like old documentation. But in this case, because this event portal tool is easily adaptable, you can have your architecture in here and you can collaborate, whether you're an architect or a developer, with each other to really understand what's going on. So let's say as a developer, if I need to develop an app now, I can of course come in here and say, all right, ride drop-off processor, I need to develop this. So I can come in here after my architect defined it, I can see the event I subscribe to, I can see the event that I'm publishing, and I can dig into those events and see the schema information and the topics that it uses. So of course I can go develop this by hand manually, but I don't want to do that, right? As a developer, I like to do things the most efficient way. And so what I'm actually going to do is there's an AsyncAPI option here. If I right click, and I'm going to download the document as YAML. And so we just quickly created our architecture in the event portal, and I can export an AsyncAPI specification file. And so what this specification file gives me is the schemas that define my payload. So I've got the ride average payload that we created, and I have the taxi status update payload, which already existed because the taxis were already sending updates into our broker. So I have those two payloads, and those payloads are attached to our messages. So we have got the ride average event or message, ride average update event or message, which references our payload for the ride average payload, and the same for the taxi status update. And so we have information here that that basically defines our messages. So we've got those two messages. And then we have the channel information here that gets taken from the portal and dropped into the AsyncAPI document that defines where we can receive or send those events to. And they, of course, reference the messages themselves. Right. And then more information
from the portal. So like right after you designed your architecture, all you had to do is you have like a different application architecture, you right click and you download the AsyncAPI spec that has the definition, the AsyncAPI definitions in there.
Exactly. So like I was able to use the event portal tool in a more like human readable, human accessible, like just more user-friendly way to design my architecture. And now, of course, machines don't have those same, they don't care what it looks like. They need a machine-readable way of basically processing your architecture, your application. And that's what AsyncAPI provides here. We can export this in a way that's not super nice for a human to read. I mean, maybe as technical humans, but a non-technical person would look at this and be like, what the hell is that? But we export this AsyncAPI document, and now
are you saying something bad about AsyncAPI?
No, just
in front of me. Really?
No, I love AsyncAPI, but it's YAML and JSON is not like it's not human readable, right? Like regular sentences that a non-technical person would read. But this is a machine readable specification, right? And so the tooling provided by AsyncAPI can now use this. And myself as a human, kind of like Fran was actually saying earlier, the specification isn't our favorite part. Like we want to use the tooling, we want to actually do things with it,
right?
Not just like fill out a specification and then end our day and have a drink and be like, yeah, I created the specifications today.
Yeah. like people do with Kubernetes nowadays. Yeah.
Yeah.
I'm a YAML developer. Exactly. So the specification is never the end goal.
Exactly.
It will be the backbone of everything, but not the end goal.
Right. You bring up a good point, Fran. Like it's like the specification could be is used as the backbone of everything, but it's not the end goal.
Yeah.
Like just a process. It's part of the journey, not the destination.
Exactly.
Exactly.
I could write this on a shirt or something.
That's a new shirt in the AsyncAPI swag store.
Specs, not the destination.
It's one step along the way. Now, it's a big step. It's a step that a lot of people and organizations have had challenges with along the way, including myself in my past roles. So we have description and other information, about your application here. So now, as a developer, I want to actually, develop this. And we said, our architect said, and we talked to our development team, and we said, oh, we want to do this in using Spring Cloud Stream. And so if you're not familiar with Spring Cloud Stream, it's essentially, if you're familiar with the Spring framework, it's a Java framework that allows you to do a whole bunch of stuff. I mean, you practically do anything now using the Spring framework. But Spring Cloud Stream is built, on top of two pieces of that framework. So Spring Boot and Spring Integration are ways that you develop highly, microservices using Spring Boot, and Spring Integration allows you to kind of implement the different integration patterns that have kind of become best practices in the enterprise over the years. And so Spring Cloud Stream is based on those two frameworks, and it allows you to create, highly scalable, event-driven microservices. So it's kind of Spring's recommended way to create these event-driven services. And one of the things that it does is it abstracts the developer from having to learn the messaging APIs. Kind of as we talked about before, there's been a lot of tooling and a lot of frameworks around to create, RESTful APIs and synchronous APIs, REST and SOAP and other things before that, but not as much for event-driven. And so, with the combination of AsyncAPI and Spring Cloud Stream, it's really makes this process easy for a developer that has not done a lot of event-driven things in the past.
Right.
So I want to show that, and so I'm going to use the AsyncAPI
into the generator. I just want to remind everyone who just joined us right now that your questions are, if you have any questions, feel free to ask them on the chat, whether you're on YouTube or on Twitch. And we also have a poll. So for those who just joined us right now, we have a poll. Feel free to fill in the poll. We just have like 2 questions to ask you. So the QR code is at the top. Get your phone, scan it, or go to the link. Thanks, Fran. Or go to the link below. Just 3 questions. It'll take you less than 5 seconds. This is for us to kind of know where to target our next events. So go ahead, Marc. Continue. After you've kind of designed the architecture and got the spec.
Yep. Yeah, I've got the AsyncAPI document, right, that defines my application. And so now, I want to generate my Spring Cloud Stream app. And so I come over to the AsyncAPI GitHub organization. And if I go into the Java Spring Cloud Stream template, there's all sorts of documentation here that, defines basically how you can use this template to do the code generation. And so it allows you to see how methods will be created in your app, how they'll be named, and of course, how to use this template is kind of the important part. So first, we start with installing the AsyncAPI Generator, which I already have installed, so I'm not going to reinstall that. And then you run the generator essentially against the Spring Cloud Stream, using the Spring Cloud Stream template and your AsyncAPI document. So this is the most basic way if you didn't want to specify any settings. But of course, we want to specify some configuration options to get the most value kind of out of the generation. And so when you scroll down, there's a whole bunch of configuration options that you can go take a look at here that allows you to add the actuator capabilities to your Spring projects, define your artifact type and artifact ID. Artifact ID is, it generates a Maven project. So artifact ID and group ID are things that you can have generated for you instead of having to fill them out afterwards. And so I'm going to go ahead and use this template. So let me go ahead and jump over to the CLI. Actually, before I do that in the CLI, I do want to touch on 2 of these configuration options that I want to use. And so one of these, let's see, XSCS function name. So this one here, the operation XSCS function name. And so what this allows you to do is essentially specify on your operation, so an operation being a publish or subscribe, what you want the name of the function to be that processes events that are from that operation in your application. And so if you use this on a publish operation and a subscribe operation, the generator will actually tie those together and say, all right, I want to subscribe to one event feed, and then for each of those events that comes in, or for some windowed group of those events that comes in, I want to create this other event. And so it creates kind of a stream processor for you. So in our case, because we had our architecture here of we're receiving taxi status updates into our ride drop-off processor, and as we receive those, we want to publish ride average updates, we are going to do that. And so let me go ahead and jump over to our AsyncAPI file. So just to show you how that would work, if I do an xscs function name, and we'll call this, maybe the name of our method we'll call process drop off ride averages. That sounds good. And so I want to use that same function name both on the publish and the subscribe operation. And then also on the subscribe side, I'm going to go ahead and you can set up a destination. So if you want to explicitly name your queue, maybe I'll call this like the taxi update queue. Let me go ahead and save that file. And so now
requirements that's needed for the Spring Cloud, right?
Say that again.
And these are all the requirements that are needed from a Spring Cloud perspective.
They're requirements to kind of tune the app. So you don't have to specify. I'll show you in a second after I generate the app what that did to make it a little bit more clear. So you guys don't have to watch me type out all the parameters I want. I'm going to copy it in here, and then I will explain it. Let me zoom in a little bit. Oops. So let me zoom in. All right. So essentially the AG command, so after you installed the AsyncAPI generator, the AG command is the command to run the generator. And then I'll go through here. I want to output to the ride drop off processor directory, and I'm missing a space here. I want to use the Solace binder. So essentially Spring Cloud Stream as a framework allows you to use different messaging systems under the covers. And there's the concept of a binder that basically handles the messaging APIs for you. So it abstracts you, the developer, from having to learn those APIs. So this generator template supports the use of Kafka, Rabbit, or Solace. So in this case, I'm going to use Solace, of course. There's two kind of paradigms to Spring Cloud Stream. So kind of the regular imperative kind of programming style or reactive. I figured, what the heck, let's try reactive as part of this. I don't have tons of experience using it, but maybe it'll make it a little bit more fun if I mess up a few times. We'll see. And then I want to include the Spring Actuator. This allows for some monitoring endpoints. I've got my Maven artifact ID and group ID. And then I've got my, looks like I have group ID specified here twice. I'm going to take that out. My Java package that I want the generated objects to go into, and then my connection information here. So I've got my host, my username, my password, and my message VPN. So that's to connect to the Solace broker itself. And then I'm pointing to the AsyncAPI file that I've downloaded, the ride drop-off processor.yaml file, and then the template that I want to use, so Java Spring Cloud Stream. So let's see. So if I throw that in, wow, that was quick. So it generated my new files in the ride drop-off processor directory, and so I can see that here. And so what this actually generated was a Maven project. So for Java developers, you know, a lot of you probably use Maven. And so I go over to my IDE, and import these projects. I can choose existing Maven projects. And then if I browse here and go to my Git repo for the live coding session, ride drop-off processor, it generated a POM for me. So I'm going to go ahead and click Finish on that. And I basically have my Java app. And so just to show real quick, I'll start with the POM. So in the POM here, because I specified Solace as the binder.
Marc?
Yeah.
Marc, can you please zoom in because we cannot see anything?
Yeah, for sure.
Thanks.
Is that better?
Yeah, that's
much better.
All right, perfect. Let me close the outline here as well. Could get a little bit more screen space. All right, so we got our group ID, our artifact ID that came from the specification, the name of our application itself, and then the generator, you know, knows how to include which dependencies you need. So it includes Spring Cloud, and in this case, we're using the Solace binder, so it included that starter. So basically all the stuff that you don't have to go figure out for yourself because the generator does it for you. It also generated, remember we had our two different payloads. So it generated Java POJOs for those. So essentially everything that was in our schema became instance variables in our Java POJO, and it created JSON mappings because the incoming data is in JSON, and getters and setters to get and set those. So we can use those while we code without having to manually create these classes. And then application.java here, you can give it a specific name via parameter if you want. I just left it as the default. Application.java is where you'll actually build your app. So earlier, when I added the function name, the XSCS function name, this is actually the name of the method that was generated right here. And so by specifying it on the publish side and on the subscribe side, it added the taxi status update payload as the incoming event to this method, and then the ride average payload, flux of each of these as the parameters to this function. Now, and this is a Java util function object, which is a functional interface. So it expects one thing in, one thing out, and kind of basically follows a functional interface method or paradigm in Java. If I did not specify those things in the AsyncAPI spec, it would have created a consumer for a consumer method or being to handle the taxi status update payload, and it would have created a separate method which was a supplier of the ride average payload. So because I wanted to handle them kind of in order or under one method, that's why I included that. And then before I jump into actually doing the coding piece, so you can see basically it set up all this whole skeleton for me, right? And it says add my business logic here because obviously we can't generate your business logic. You have to add that yourself.
That's the next step. Machine learning and AI to generate your business logic.
That's for the next version. Generator version 2. Yeah.
Version 2. Yeah.
Yeah. We're working on that already. It's gonna be really soon.
So when you look at this, you might say, "What the heck? There's no messaging anything in here," and that's kind of where Spring Cloud Stream comes in. It abstracts that away from you. So this is just a regular Spring Bean. But if you go over to the application.yaml file, this is where the Spring configuration takes place. And so the generator actually generated the skeleton and the configuration behind the scenes for you. So it wires up that function that it created, and it wires up the channels here that you are publishing or subscribing to receive or send events. And so the input side is listening on my queue that I named in the YAML file, and the output side is outputting to the topic that I defined. And so because we are using the Solace binder, our best practices are publish to topics and consume from queues, which is why the binder, which is handling the messaging API part for you, does that. And so in Solace on a queue, you can basically specify subscriptions. So if we remember back on our diagram, let's go to this diagram here. We have incoming events on topic 1, and they have this hierarchy. So I actually want to listen on just drop off greater than. So in my file here, I'm just going to go ahead and change the topic that I'm subscribing to use that wildcard. And then I'll only get those events when I start up. So I'll go ahead and save that. And so I don't have to do anything else from a configuration perspective to actually connect to the Solace broker and start receiving events once I have my business logic created. So the generator did all that for me. All right, so now from an application perspective, what do we actually want to do here? Now we want to write our code, right? So what we want to do probably is we want to break the stream of taxi updates into windows, and then probably aggregate the events in those windows. So basically collect that information together for all the events that happen in that 20-second interval. And then once we have that information for that 20-second window, we'll calculate the window averages in the ride average payload objects so we can stream those out. So I'm going to go ahead and to do this, this is where I'm not.
Your architecture diagram, the stream of events that's coming from the taxi updates, they have like a payload, and what your Spring Cloud microservice would do is kind of like just consume this JSON object from like the streams, and then over a window of 20 seconds. So it'll just consume it over to a window, or like a window, regardless how long it is, and then it will calculate the stats, right?
Yeah, exactly. So all these events are flowing in continuously. This ride drop-off processor is subscribing to only drop-off events because, you know, it doesn't make sense to calculate like the average cost of a ride, you know, maybe throughout the I only care about the cost at the end of the ride, right? Like when I pick up initially, I don't really care about that cost, or like the 100 or 50 or 1,000 updates along the way,
right,
throughout the ride. I just want the end when I drop the passenger off. What was the total cost? And so those are the events I'm interested in. And so this application is listening for just those events, and it's going to receive all the drop-offs in a window, and it's going to process the averages and republish those out on the drop-off average topic. So if I go back to my IDE, the first thing we want to do is break it up into windows. And so I guess let me touch on one thing real quick. If you're not familiar with Project Reactor, essentially when I chose reactive, the reactive parameter on the generator, it used flux here. So flux essentially in Project Reactor is a stream of 0 to n elements. So because we have an infinite number, or we're going to keep getting updates from taxis forever, in this case, we're using a flux, and so we want to process that stream of events, and we're going to have continual windows going out, so we're using a flux there as well. The other kind of common publisher in Project Reactor is mono. So if you know you're going to have a stream of 0 or a stream of 1 event, then you would use mono. But we're going to break the stream up. So what I'm going to do is I want to return flux. Let me get rid of the return null. And I want to window that. So if let's see. Actually, let me, just to make sure we see things as we go, I'm going to add a log and then window on that. So what am I doing wrong here? Flux. It's a lambda function. And so I want to do a window. And so in my window, I said I wanted to do 20 seconds. So I'll do of seconds 20. And so what this does is it's breaking my flux up into windows of 20 seconds. And then on those, I'm going to call a flat map function to say, now for each of those windows, I want to calculate the average. So I'll just make a separate method to calculate the average. Doesn't exist yet, so I'm going to go ahead and create that down here. And so for each window, I know I'm going to have one average, which is why I'm going to return a mono from this. So if I say calculate average, I'm going to take in my flux of my taxi updates. So grab that here. We'll call this a flux as well.
Yeah, this is all Java magic, right?
Yeah, Java magic.
Right.
So the cool way is just with Project Reactor, it allows you to do some of this windowing and stuff. So kind of by default in a lot of event brokers, you process events in a distinct manner, so like one event at a time, and they're separate to most brokers. And so Project Reactor allows me to do these things like windowing and processing those events in a window, which is pretty cool. And I wanted to get more experience with it, so I was using that as part of this. So now that I broke it into a window, and I basically created this function, and down here, I want to aggregate the events that are in these windows to collect the information. So in order to collect the information, I'm just going to create a accumulator class to keep that information. And so in order for us to calculate the averages, we need the ride count, so we can basically total up the cost of all of our rides in a window and divide by the ride count, and same for the passenger count. So I'll do let's see, a double total meter. So we need our total meter, and then we need our total passengers, and we're never going to have partial passengers, so I'll make that an integer. All right, and so I don't have to create all these getters and setters. I'm going to use Project Lombok which is kind of something cool that's from Spring. So it allows me to, well, actually I need to add it. So this is actually recognized as a Spring project. So I can edit starters here and add Lombok. So this is pretty cool if you have a IDE that you're using Spring Tool Suite in. And so now what this allows me to do is, so essentially now in this, I'm using a Lombok here to generate the getters, setters, and constructors, so I don't have to do that myself. Keeps my code short, right? So
is this kind of like a package that you kind of include with your application?
Yeah, it automatically gets added by the compiler. So just to show you, so essentially, usually in Java, historically, if you had your class members here, in my accumulator class, I would have to create the getters, the setters, the toString, the constructor, and all that. Right. But using Project Lombok, let's see if why is it not loading it for me? Okay, I think I have to actually have a class that compiles here. What do I have wrong here? What am I missing? Class accumulator, ride count, using Lombok. I'm missing a semicolon. If anybody sees what I'm missing, please feel free to jump in. Ah, here. I think I'm just missing a paren there.
A bracket?
Yeah, maybe. Let's see. Where does this close? That closes there. No. So let's calculate average.
What does it say when you hover over flat map? Because it looks like the error starts there, right?
Oh, here's my mistake. There we go.
Okay.
I had an extra paren in there. All right, so now if I import these things, so you can essentially see, by default, when I import these, so this is Lombok data, and I say I want an all args constructor because I want to create this object, specifying all the parameters. It actually creates all of these getters and setters for me, and unfortunately I can't zoom in here. But I guess you can trust me. There's a getter and setter for each of these three. It also creates equals objects and hash code and toString and stuff, so I don't have to do that myself, which is nice to keep it short. So now that I have something to aggregate these into, I actually want to return the flux, and so I want to reduce those things using my accumulator. So I want a default accumulator, and I'm going to start with 0 of everything, right? So I have a ride count of 0 before I get any events, a meter count of 0, a passenger count of 0. And then the next parameter here, as part of my reduce function, is to actually populate or decide what to do for each event that comes in my window. So the A will be accumulator, and I guess the D will be like my next, I won't use D, I'll use taxi update. So for each taxi update, I essentially want to create a new accumulator object. And I want to create a.get ride count, so my accumulator before, and I'm adding one more ride to it for each event, each ride that we get. And then I'm going to get the total meter, and I want to add the meter from the new events. So get meter reading. And then the last thing is the total passengers. So I want to get the total passengers, what I've accumulated so far, and add the number of passengers in my latest taxi update. So passenger count, we add that, format that a little bit.
And the goal for this is you will have this in your payload once you publish the message to your topics, basically.
Yeah, so my goal here is that I am accumulating the data so I can actually calculate the averages. So now that I've accumulated the data, I want to actually map it. And so let me just format this a little bit here so it's a little bit nicer. Do it on one screen. Yeah, there we go. So I basically am calling a reduce. So what the reduce is doing, it's taking this flux, which remember a flux is 0 to many events. So I'm getting the taxi update events. I'm accumulating those into an accumulator. So I'm returning an accumulator object that we created here. So at this point, I have one object that knows the total amount of rides in my window. I know the total meter amount, and I know the total number of passengers. So now I just want to map that accumulator. So we'll call it accumulator here. And I need to create my new ride average payload. And so as part of that, we don't want to delete. I just basically need to calculate my averages now. And so let me, want to create the new payload, and I want to say accumulator dot, let's see. I want to get the total meter is the first thing, and then accumulator dot get ride count. So that's the first thing, and then the second thing is the size of the window. So in this case, we're doing 20 seconds since we did that above. And then again, we want to do the accumulator at total passengers. So we want to create the average for the passengers. So total passengers, and again, the average will be the total passengers divided by the number of rides. Ride count. And then lastly, we just need to add a date to this. And so for the date, we'll go ahead and just use the current date. And so to do that, I'm going to add a few things up top here.
Yeah, I've never
a simple date format.
I've never used Lombok before, Mark. I've never used Lombok before, and it's actually pretty cool how like it does all your getters and setters for you, and it just facilitates the process, the overall process, makes it more efficient.
Yeah, for sure, and it's nice because if you update things, it's all in one spot. So at this point now, I'm mapping my accumulator, and let's see what's it complaining about. Oh, I think I know. Because I'm doing I need to cast my accumulator to a double, so I get a double returned. An int divided by an int, I believe, return. Okay, now what does it want? All right, so we need double integer string. Oh, I'm missing an argument. So let's see here. If I look at my ride average payload, the constructor actually wants average meter reading, which we have, window duration, which we have, average passenger count, which we have. Oh, I'm missing the window ride count. So the fourth parameter should be a window ride count. So I just want to get the accumulator dot get ride count there. And now if I reformat that, now we're happy. All right. So we have now, if I put the comment in the right spot, so let's look at what we did real quick. We broke the stream of taxis into windows, and then for each windows, we called calculate average. And then in the calculate average, we basically aggregated the events in those windows into an accumulator. And so we collected our total number of rides in the window, the total meter, and the total passengers. And then we use that information from our accumulator object to create the ride average payload. And so that's what's being returned out of the calculate average. And so for each window, we're returning a mono or one average payload. And that's collected up and returned as a flux. So of course, your business logic might be different. You might also just include the imperative, or might decide to use the imperative Java style if you're more familiar with that, like I am. But I decided to embarrass myself in front of everybody by learning something new. And so now I've added my business logic. I can go ahead and just run this as a Spring Boot app. And so theoretically, this should just start up and connect and run. And so we can see, because I added the .log options, for every taxi status update payload that comes in, essentially internally, Flux is getting called with a on next. So for each event, we get an on next, and we can see those rides coming in. And then after 20 seconds, we should see the window. And there we go. So we received events for 20 seconds. And we see our mono being created here, where it created the ride average payload. And we calculated our average meter reading was 1473 over that time period for the window duration of 20 seconds. We had a ride count of 6 drop-offs during that time, and a timestamp tagged for our event. And so just to make sure that I'm getting those events, let me go check it out in the Try Me tab just to show that. And I'm using a instance in Azure, and so in Try Me, I can actually subscribe to those events. And so if I connect and my topic.
So now your app is running, your microservice is running, Marc, right? Behind
yep.
Scenes, and it should be publishing to the topics that you defined in your microservice. Now, what are you doing?
Yep.
What's the Try Me app that you're showing us?
Yeah, exactly. So essentially, the Try Me app in Solace Cloud allows you to connect and publish or consume events that are flowing across a given broker. So in this case, I'm now publishing my events on the stats drop-off average topic. So just to prove to myself, like I know my app's running and I'm seeing logs, but I want to make sure that it's actually running before I hand off to Fran and say, process these events. Yeah, I don't, I'm a developer advocate. I code quite a bit, but it doesn't mean I don't test my code before I go to production. Maybe sometimes I might go to production. You never know. All right, so I want to listen on this topic. So taxi New York City V1 stats drop off average. All right. So taxi New York City V1 stats drop off average. And so if I subscribe to that, I should get something like every 20 seconds here. And there we go. So I can see that I'm getting an event. And so at this point, you can see that basically how easy it was for me to go from design to using the AsyncAPI Code Generator to create the app skeleton. And then I had to add my business logic, which for me was not as easy because I had to learn how to use Project Reactor a little bit. But once I got that going, I basically just hit run. And my microservice is running, receiving the events from the taxis and publishing the average events. So we've now created our first microservice using Spring CloudStream and the AsyncAPI Generator. But now, if I go look at our architecture here in the event portal, that's the first piece. So we have the taxis sending the events in. We have the ride drop-off processor creating the ride average updates. But now we want the ride drop-off consumer created. And so in the description here, we said, we knew that Fran is going to develop this. And Fran's not a Java guy. He likes to use Node and other applications. So we said this is a NodeJS application. And that's fine. Because the Solace broker allows you to use different languages and different protocols and APIs.
Right.
Like I'm using Spring CloudStream, which actually I can show you really quick, and then I'll hand off to Fran. But we support different APIs and protocols. Oh, you like that, Tamimi? Zoom in.
Nice. I was just gonna say, oh, nice zoom.
Nice skills. You can include it now on LinkedIn.
Yeah, zooming in capabilities, yes.
Yes,
so our Spring CloudStream binder here actually uses our Java API under the covers. So it's a Solace SDK publishing into Solace. But just because I'm using Solace message format and I'm using a Java API, I can communicate with these other applications. So for example, like the taxis would probably be using C or Python maybe to publish events over MQTT, just as examples. Now, Fran is actually going to use JavaScript or Node.js to receive events over MQTT, and the broker itself is doing the protocol translation. So he doesn't have to care, his application doesn't have to care that I'm using Spring. He's just going to use MQTT and connect into the broker. So again, the applications are decoupled. He doesn't care anything about the publisher other than that the events exist on the topic that is in the design.
Right, so, and that's the nice thing about this. Like, it's a pure microservices design where, as application developers, yourself and Fran, you're completely decoupled from the taxis portions. We don't even know how, and we don't need to know how the taxis send their data and what programming language you use or what protocol you use. As long as they use a programming language and protocol and they send it to the broker, these different microservices, even like if we're in a real world where Fran and Marc could work on the microservice in parallel, where Marc and because Fran already knows, for example, like any application developer or in developing the microservice already know the schema, and everything is defined from the technical requirements. So what are the requirements for your application, your architecture? It's already there. It's already defined in a spec, and you can see like the other microservice is not dependent at all on how Marc's microservice is being built, as long as Marc's microservice follows the spec and follows the schema. And that's the nice thing about it, where like Fran, now I would like to kind of like see like your input on this. Like, what do you think of the whole process? And we'll pass it on to you.
Yeah, so that was the whole idea about AsyncAPI, right? So defining the interfaces, right? We don't care about the implementation. So that's why we can communicate a Java service with a NodeJS service or with whatever other service. And we care about the interface. And the interface is composed by primarily first is we need to understand where the broker is. So that's what we call servers on the AsyncAPI specification.
Right.
Then what's the protocol? Of course, what's the protocol that this server is speaking, or the protocols, right? It can be many, like Solace does, for instance. You support many protocols, right?
Yep, exactly. So Fran, I went ahead and pushed the stuff into the GitHub repo, so you can pull it down if you need to. It's on the live stream branch.
Awesome.
Yeah,
I already did it. So
perfect.
Yeah,
You're way ahead of me.
On my machine.
Anyone who's watching online, you could check out the GitHub repo over here. We're putting everything live. You could follow along. You could ask questions, and you could feel free to contribute and let us know what you think so far. So Fran, now I'm going to pass it to you. So let me know if you want to share your screen or not.
Yes.
Could you share the architecture diagram?
Let me try to share it.
Scroll down to the architecture diagram over here to show what we did. Now, yes, this is it.
Yeah.
Fran could take that piece now on the bottom right. If you zoom in, perhaps maybe it's.
Let me try.
There you go.
Yep. And so, and then Fran, you want to go ahead and share your screen, and then we'll.
Yes, I'm on it. Actually.
Okay, perfect.
Find which window it is.
Okay. Yeah. So what Fran's going to do now is basically those events that I subscribe to in the Try Me tab, the ones that are being put out on stats drop off average. He's going to consume those in a Node.js application.
Right. Quick question to Marc and Fran came from Twitch from Aaron. Does AsyncAPI have a preference or capabilities specifically for hierarchical topics, or doesn't matter? Flat topics are okay too.
Flat topics are okay too, of course, because they have to, because not every protocol supports hierarchical topics, right?
Right.
So yeah, it was a must. Like for instance, you have WebSockets, which is a very common case. You don't have that. You only have the event name, which is a map to the topic, and it's just a plain string. It doesn't have any meaning. No characters have any special meaning.
Yeah, and I would say, so AsyncAPI definitely supports either way. From a Solace perspective, like we have topic best practices that are out there, so definitely like using the different levels is great. It's a best practice for Solace, and it's good for allowing, like, you want the topic hierarchy in a Solace best practices perspective to define what the actual events are. So it kind of defines your event stream, so your subscribers can choose which bits and pieces of the event stream that they want.
Absolutely. I mean, my personal recommendation is always, if you have them, use them, because they can save you a lot of overhead, let's say.
Yeah.
Because especially in performance, right?
Right.
Like we were saying, that the taxi topic was a great example. That we had the window or the number of passengers, I think.
Yeah, passenger. We got right here.
Yeah, so you don't want to probably, you're not interested in rides that have less than 3 passengers, for instance.
Right.
You can filter out. Otherwise, you will have to filter out in your application, and that means you will be receiving a lot of messages that you're not interested in actually.
Yeah, exactly. Like, and that was, and so I subscribed to like the drop-off events when I was doing that. If I did not do that, like, I think this event feed has like 2,000 events a second almost. So, you know, in a 20-second window, I got 6 drop-offs. If I didn't filter on just the drop-offs, I would have got 40,000 events that I had to throw away.
Yes, exactly.
So a lot of network overhead was saved there.
Yeah, right. So it's important. Yeah, of course it's important.
Fran, I'm going to your screen.
Yeah, sure. Okay, perfect. So yeah, we have here the AsyncAPI file that Marc just exported, and as you can see, this is the. Let me just come here. This is the file that he just exported with the write averages update message. And it has defined a payload here, and we're going to be getting the messages here on the drop-off average topic, right? So let me just go through the generation process. So I'm going to use the AsyncAPI generator, and I'm going to specify that I want to generate this specific AsyncAPI file. And I'm going to use the official Node.js template for AsyncAPI. So that's how you'll do it. And this template, I'm sharing. I'm sharing just the code editor window. Otherwise, I'll go for showing documentation. But this template requires you to have to specify which server you want to generate. So let me try to find it here. You see that there is a servers section on the AsyncAPI document. You can have multiple here, right? So one way to optimize your code is to tell the code generator which server do you want, right? Because now this one is Solace, but imagine that you have 3 here, and this one is not called Solace, but it's called prod, right? Staging and development, right? You don't want to generate all of them, right? You would just probably want to generate one of them. So, yeah, that's the reason you have to specify a server. So I'm gonna pass a parent to the code generator, and this is a server parent, and I'm gonna specify that this is the Solace one. Let me also put the result of this generation of this generated code in a folder called code. Maybe I'm just inventing this name right now, and it's like whatever. I just don't want to generate the code in the exact same way in this directory, right? So we don't mess up basically. Okay, so let me run it.
So for my node, for this generator that you're using, what are the other protocol options besides MQTT?
There's no much. There's not much here. Most of them, maybe. Let me try to find.
Oh, sorry. I can look it up. I wasn't sure.
Yeah, it's because I'm only sharing the code window. Let me just.
I stumped the founder. Okay, I'll look it up real quick.
Okay.
Oh, I see. AMQP, MQTT, WebSockets, or Kafka. Looks like.
Oh yeah. Regarding protocols, yeah. Sorry. I thought you were meaning about all the params that you can pass.
Oh no.
Okay.
Yeah, so,
like, I don't know.
Come on, Mike.
I don't think there are many, but in this case. But
from a Solace perspective, MQTT is definitely the way to go out of those, I'd say.
Yeah. So summarizing, you can see that we got generated code here on the code folder. So I'm gonna get there, see the code, and for those who are familiar with Node.js, this is common, right? npm install. I'm gonna install all the dependencies, and it shouldn't take too long. Cool. So one of the things that I'm gonna make it fail just for you to see what's happening. So I'm gonna do something. I'm gonna run npm start, and this is gonna fail. Okay. So we got the problem here. I'm gonna stop it. And it says connection refused by the username or password. Of course, we have the Solace server. The only information that we have about the Solace server is just that. We don't have a username or a password, right? So we have to go to the config file here and specify it, right? We have to specify the username and the password. Let me just get it. I have it here somewhere.
Yeah, I think it would actually work if you're running a local Solace, but obviously from a cloud service perspective, we make sure you have to authenticate to use the cloud service.
Right. There is a parameter if you scroll down as well, the configuration parameter under the broker. So you see here in the common.yaml, there's the broker section, and then when you go down, there's the configuration parameter as well that you could that you'll need to add to this.
So. Yeah, in this case, so I had already the username and the password here. Because the cool guys from Solace gave me beforehand. So so yeah, we have the username and the password. I'm gonna run it again. Just recap again. Let's see. So cool. We got success here. It says it's subscribed to the topic. It's ready, and it's listed the MQTT adapter because it's an MQTT server, because we're saying it here, and then on the AsyncAPI file, it's connected, so it's listening, and we got a message, right? So it's success.
That was easy.
Yeah,
that was so freaking easy, right? So we got here the timestamp, the average, all the information that Marc is pushing from the server he just created. And yeah, as you can see, we're receiving messages every once in a while. It's every 20 seconds.
Yeah.
Yeah, we got another one, so perfect. So yeah, you saw how easy it was to actually generate the code. Just a quick walkthrough of what's happening here. We're using a library called Hermes. And this is, for those familiar with Node.js, this is like Express, but for messaging. So yeah, and it's just using middlewares like Express. So it's saying the application to use this middleware, which this middleware in turn is actually a route. So it's actually, yeah, you see, it's subscribing. It's using this. When it says use, it's like it's subscribing to this topic. And then you get the message here, right? And you can do whatever you want here on the handlers. So it's another handler is created, and this will be the equivalent where Marc was writing all the business logic. And as you can see, you get the implement your business logic here. Something that we will have sorted out soon. We'll generate the business logic for you.
Right. Yeah.
We will get.
That's cool.
It's not getting it.
This is nice. This is pretty nice. I actually had not seen this before, so I'm getting to learn something here too.
And Fran, correct me if I'm wrong. So similar to like when you develop your Node.js application, if you're developing a Node.js application and you want to handle REST API calls, so let's say you're developing your Node like JavaScript application, whether it's front end or back end, and you want to handle requests from your REST APIs, you use Express, for example. And from an asynchronous perspective, you can use we're using Hermes to kind of handle any messages or any events that are coming from the topics that we are kind of like listening to or subscribing to. So it's the same way to compare. Like I usually try to kind of like compare things.
Yeah,
and then Hermes.
It's actually a little bit more because it's not just to handle the incoming messages, but it's capable of handling the outgoing messages. So whenever you try to send a message to a topic, you can apply certain middlewares to manipulate the message before it's actually sent. And one of the things that you can do is to validate that the message is valid. It's well formed compared to the AsyncAPI definition. So you make sure that you don't publish any message that is not looking correctly or well formatted, right?
Right.
And same on the incoming messages. You can validate them as they arrive to your application and make sure that it has the correct format, right?
Where does that validation happen? Like, can we?
No, that's something that we want to include next.
Yeah.
Okay.
I have some sort of prototype that we can use if you want right now, and with this example. And if you want, we can use it if we have time.
I think
we can make it fail if you want. And make it
right now we have like the schemas being defined, the payload schemas being defined in the AsyncAPI spec. And Fran, I don't know, do you have access to the GitHub repo just to show the overall infrastructure architecture? What we literally did right now, 2 microservices, one in Spring Cloud, one in NodeJS. And the Node.js just subscribes to the topic and puts it out. So what we could do is, because there are some stuff in the AsyncAPI spec that we haven't used yet. So such as the schema. So for example, like we showed, like Marc showed earlier, that you could define the schema, the payload schema, with the JSON schema of like what you have. So I'm actually kind of intrigued and curious to see how, from a Node.js perspective, how can we make sure that Marc is sending the right schema on the top.
You don't trust me? You don't trust me?
Never.
All right, let's do it.
Yeah, that's a good point. And I want to just remark one thing is we're already using this information about the schema. If you look at the screen right now that I'm sharing, you have all this documentation, right, about the average method reading equal default value is 0. Window direction second default value is 0. Blah blah blah, right? All this information is taken. So all this documentation on the code is generated from the schema, right? This JS docs.
Talk about test-driven development, where you have your schemas already there, so you could literally even like have tests in advance, and like you could build your microservice to even confirm other microservices to see if like the payload is coming right. Because if, for example, let's say in a hypothetical situation, Marc put the like a parameter, for example, like a timestamp as an integer, this would fail because like we put in the schema that it's there. So we could like go ahead and see what we could do with this. Just a quick kind of update to anyone who's watching us live right now. Your questions are accepted if you have any questions. If the overall architecture wasn't clear, let us know, because what we did right now is, to recap, we went from designing an architecture on the event portal, on the Solace Cloud Event Portal, defining all the schemas, downloading the AsyncAPI spec, installing or developing a Spring microservice, Spring Cloud microservice, and a Node.js microservice, and they're harmoniously, asynchronously working together right now. And let's try to challenge Fran a little bit. This.
Let's check out the new feature. Yeah, I'm excited to see this.
So yeah, let me just. I'm not sure. I'm not sure I'm sharing the right window. Okay, so let's live event. Okay, correct. Cool. So yeah, so I'm here. You see me moving stuff around, right?
And so you're using a future version, essentially, is what you're going to do now?
What?
You're going to use a future version, like a new feature?
No. It's actually a package that Walid, one of our community members, right, created, and it's a Node.js package that allows you to take AsyncAPI from input as an input, and then whatever JSON value, raw JSON value, and compare if they're valid, right? So that's what it does, and it kind of maps to AsyncAPI, right? So not gonna extend so much on how it works, really, because this could be really boring.
Yeah, no, it's fine. As a developer, though, like I would basically just add a parameter and say, hey, validate, and then the generator would plug it in for me.
So basically, look. So if you look here on the left side, we have a middleware's folder, and these are the ones that are logging the messages as they arrive, right? And one of this is validate, right? So here I'm using this library of Walid that it's called AsyncAPI Validator, right? And what it's doing is, as we get a message, it's gonna use the library to validate it, and if it fails, it's gonna continue the pipeline, right? Because this is like a middleware pipeline, but with an error. So it's gonna notify that an error happened. Okay, so the error logger, which is the one that we have here on the left side, will take care of logging it properly, right? Or doing whatever you need to do with it. And if everything goes well, it just silently continue the pipeline, and that's it. And it will at some point arrive to your business logic. Okay.
Okay. Makes sense.
That's a pretty simple concept, I will say. And we're importing here the middleware just to make sure, and we're using it here. So one of the things that I've done beforehand is say validate this message. So nice. This message, right, averages update is taken from here, from the AsyncAPI file. It's this one, right? So I added this name here, so it knows which one is it. And let me just save it and cross my fingers. I'm gonna stop the other one.
I'll cross my fingers for you too as well.
Thanks.
If it says my stuff's incorrect, I'm gonna deny it.
So I'm gonna validate it. Yeah, it didn't fail, so it's valid. One of the cool experiments that we could do here right now is we can actually do the opposite. You can change your code if you want and make it fail.
Go ahead, Marc. Let's change.
I don't think Java will let me, like, unless I change the objects themselves, right?
Okay, let me do something else.
Can you do, if you change something in the spec, right?
Yeah, I'm gonna change the spec, exactly. It's just gonna be easier. So yeah. Okay.
So this is cool though, because like historically, like a lot of, again, kind of back to the, event-driven applications are decoupled, and when you have problems in these systems in operations, a lot of times everybody just points their finger at the middleware team, and the middleware team's like, I don't know, there's events there, like I see stats going up, but this will allow you to actually like validate, like, and figure out, like, if you can tell if
in your code,
if the what's flowing across the pipes actually matches the design, will help you troubleshoot that much quicker.
Yeah, exactly. So here you see that we have this average meter reading, and it says it's a type number. We're gonna change it to string, and therefore the default value is gonna be string of 0. So that's it. I think that will be enough. Sorry. I actually have to do it here on this file. The other one is the original one, where I generated the content from, the code from.
Right.
So let me just make sure that everything is here, and I think it is. Yes, here it is. So it's default 0 string and it's type string. Okay. Mm-hmm. So let me start it.
So now technically, microservice will send it.
Oh.
I mean, I guess it could just parse it as a string, right?
Yeah, it's probably doing typecasting or something like this.
Yeah,
automatic typecasting, Node.js, beautiful things.
Yeah. How can we make it?
So change it to a Boolean.
A Boolean.
What?
A Boolean.
Change it to a Boolean.
Okay, yeah, that's true. Let me just.
Because if it says that my ride count of 3 is somehow a valid Boolean, then I think the validator has a problem.
Yeah, exactly. If it casts to Boolean from a number, from a number, it's possible as well.
Yeah, I guess do the.
I'm gonna do an object.
do the timestamp. Change the timestamp. The timestamp won't be a 1 or 0.
And to give a shout out to community members, this validator was created by Walid, so you can see his Twitter handle down there. Walid contributed to the validator on AsyncAPI. This is a pure example of how open source is built by the community, and anyone could go ahead and develop. So Walid, if you're watching, shout out to you. Thanks for developing this. Thanks for contributing to open source. So yeah. There you go.
Yay, it failed.
I'm so excited that it failed.
So here, I changed it to something really different, which is an object, right? I said type is object, but actually type is a number.
Yeah.
So yeah, you can see it logged here anyway. Like, where is it? Is matter reading
what the issue was?
Yeah, this one. Yeah. So this one is a number, as it should be, right? But on the AsyncAPI file, we're saying that it will be an object.
That's actually
right, because we're saying that it's an object. We're expecting an object, right? Like you can see here. So that's why it's failing, right? That's why it's correctly failing. So yes, and I think that will be like all from my side in terms of showing live code. I'm happy to take any questions, of course.
Perfect.
And
that's great. I really enjoyed this kind of like end-to-end application to show how we could, work in different microservices together, design, architect, even validate things. So we covered like a good ground over here, and we're on time. It's good. We have a good amount of time, which is great. So I want to give a quick reminder to anyone who's watching right now to join our Solace community. There's like updates there to stay up to date with our future events. We'll be posting events, so you can see near Fran's head. There's a QR code where you could scan it right now over here, which is great. So thanks for that. No, I just wanted to kind of
so real quick, Tamimi, on that as well. We are the Solace community will have our event schedule pretty soon, and so we do plan on doing weekly events. So I think most of the time they're going to be on on Wednesdays. So by joining the community, you'll also be notified of future events and be able to go in there and see the schedule and stuff as well. Yeah. Sorry, Tamimi, go ahead.
All right, we got a question from Twitch that just came. So this person uses NodeDev123, but also plays with Spring, Java for backend. What other languages can I use with AsyncAPI?
So far, I think it's a NodeJS, Java with 2 different frameworks. It's Python, right? It's the other template. And I remember a community member saying that they had a C++ code generator, but I'm not sure if they open sourced it or not. In any case, this is something we're working on. We're continuously working on. Actually, we're actively creating new code generators ourselves in Solace as well. So we're partnering there, right? So, and actually, the Python and the Java Spring Cloud Stream code generators were created by
and Solace. Anybody contribute to it as well. So this is actually like a pretty cool go.
And we'd like to remark here that most of the times, the only thing you need to do if you want to have a code generator with your favorite language, you only have to put a simple project in a repo and tell us to review it. Even if we don't know so much about the language, we can help you convert it into a template, right? So it doesn't need to be perfect. It's just a starting point. Because once we have a starting point, then people will be more keen to contribute and improve it, right? Yeah. So that's for instance how I did it with the NodeJS code generator, right?
Right.
It was like that basically. I created a proof of concept, and then people started complaining about it, right? So it's like, but that's how it works. It's like I knew that it had bugs and it had really bad things and decisions, but the moment you have something working, or you feel that you could have something working, you only have just to fix this. Then people are more keen to go and fix this only. But to tell people to start a new project from scratch and contribute it and all of that, it usually takes more
sweet
from them, right?
Thanks, NodeDev123.
Thanks, NodeDev123.
So I guess kind of on that note, like Fran, if people want to contribute to AsyncAPI, like how should they do so?
Yeah, so one of the things that we always say, if you want to really contribute, join our Slack workspace. I think you have the URL somewhere on the banner. Yeah, there you
go.
So if not, you can always go to the website and you'll find it on the top menu. But I think the first step will be this. If you're not a fan of Slack, we can understand. It's also fine to just open an issue on the generator on the generator repo, so that we can help you, or we can answer your questions, or we can actually collaborate. Because to be honest, Slack works better, right? It's like more real-time chatting tool. It's not like GitHub issues. It might take one day for us to reply or two, right? It's not that live, right?
Yeah, so, I will say, so I'm part of the AsyncAPI Slack workspace, and
really,
it is a very just a little bit,
That's why I know you from.
And it has been a very welcoming community. Like, people are always introducing themselves, and it seems to be growing with the initiative. And definitely, I feel like sometimes I'm asking questions like late in my day, and since I'm in Orlando, I don't expect answers till the next day. But Fran and Lucas and everybody else there, I don't think they sleep. I think they answer Slack messages like all night.
I told you, man, we're developing the next generation generator where it generates the business logic, and one of the core features is machine learning and natural language processing. So it actually replies to you. It's a bot replying to you. It's all about.
That's fantastic. Well, I'm really happy that we were able to get this working from architecture, design, and working microservices. Yeah. Fran, you said you have something else to mention?
Yeah, just one thing is we're slowly rolling out a new tool, which is the AsyncAPI Hub, and I think you should subscribe there. You should sign up here.
There you go.
Yeah, it's a cool. I think it's going to be a really cool application and tool, right? It's open source, and yeah. So let's also collaborate there. It's like an IDE if you want, or a SaaS where you can store your files,
right,
and have projects and share with your team, and so you can share the AsyncAPI files with your team and collaborate on them, right?
Yeah, I'm excited to see Hub, right? Is it when it's going to be available to everybody?
I hope soon. I mean, it's going to be soon, but I hope when I say soon is within the next month, within the next month time frame. So it's let's say during the next 30 days. Let's say like this, so it's not confusing.
So Christmas.
So Christmas, yeah, more or less.
In July.
So. The reason it's not yet open sourced, it's not yet available for everyone, and it's not ready. It's as stupid as we don't have a website yet. So we don't have a website. We have the application, and we don't have a landing page. Yeah. And also because we want to open source it with some decent documentation, right? So people can start building on top of it. Because I love to explain this about AsyncAPI Hub. It's a pluggable, or it's made of a pluggable architecture if you want, or it implements a pluggable architecture. So it's easy to create your own plugins for Hub that do whatever you need to do on Hub, right? So yeah, one of the things that we have to explain really well is what are the plugins API. How they work, how to develop plugins for the UI, plugins for the server side, plugins for the database, how to store custom data on the database. So it's
and we wonder why you have no time to do anything else.
Sorry?
And then we were wondering why you didn't do anything else outside of AsyncAPI.
And I even I didn't even mention half of the things that I'm doing. So, I'm moving to my hometown right now. So, like in the next days, I'm moving to my hometown, which is 1,000 kilometers from here, and we're in the middle of a pandemic, and an emergency state on Spain. So yeah, it's fun.
Well, good luck with that. Hopefully, congratulations. Hopefully for moving back to your hometown.
Yeah, finally.
Yeah. So while we're plugging tools, I just want to plug one more thing, I guess, is I don't know if I mentioned it earlier, but the console that I was showing in Solace Cloud, you can sign up for free and you can launch like a free developer messaging service. And you can use the event portal. There's like a free trial period, I think it's 60 days. So you can use that to generate your AsyncAPI spec and check it out just like we did on this session. So
yeah, cool. I think this kind of like finalizes everything. So Fran, again, thank you very much.
Thank you.
Thanks, guys, for inviting me. And thanks, Trish.
Trish is behind the Trish.
And nobody is actually not there, but thanks for all the cool work.
Yeah.
Thanks, Trish.
Here's Trish.
Oh, there she is.
Hi, Trish.
Thanks, guys.
Great. Thank you for this. And again, for anyone who didn't get the chance to fill in the poll, please go ahead. This is your last chance to fill the poll. But apart from that, all I have to do is just one thing.
You don't have outro music? That's me.
Oh, outro music.
So he's been like in like all the meetings we've had like the last 2 weeks. He keeps having outro music. I'm like, how can you? He has it for the meetings and not for the live stream.
That's an interesting concept. I'm gonna start doing this.
Yeah.
It's a good idea. You could just like have your music all around.
Abba. Nice.
Yeah, Abba is my thing. All right.
Thank you. Have a good day.
Take care.